Alright, let's continue with the second type of transient circuit, that is RL circuit. That means a circuit with resistor and inductor, right? So again, a few important things that we need to know is that the formula for time constant for an RL circuit is L over R, right? For RC circuit was R times C, but for inductor is L over R. And of course, it is a time, so the unit is second. Okay. And secondly, anything that is increasing is with a bracket, decreasing is without a bracket. So for example, if I say VL and if I say VL is if I were to say VL is an increasing function, you would therefore say it is E1 minus E minus T over time constant, right? And then if I say it's a decreasing function, then you say E minus T over time constant, right? Anything increasing or decreasing, increasing is with a bracket, decreasing is without a bracket. Okay. Actually, your VL can never be. Okay, let me phrase it again. Sorry, let's phrase it again. Let's talk about anything that is increasing. If I would say IL, the current through the circuit, I, increasing function, it will be with a bracket. Alright? A decreasing function without a bracket. Okay? So this is the second point I want to say. Increasing is with bracket, with decreasing is without a bracket. Third, phi time constant. It takes phi time constant to reach steady state. Okay? Alright, so with this basic knowledge, let's talk about first case where I have a resistor and inductor in series. 20 volts, this is equal to 5 millihenry, and this is equal to 6 kilo ohm, right? And the switch is closed at 0 seconds. Okay, now this is called the voltage across the inductor, this is the voltage across the resistor, and this is the current. Now the story goes like this. Inductor is a very stubborn element. It's a very stubborn person. He has this characteristic that he wants to maintain no change. So before the switch was closed, there is no current passing through the circuit. Agree? No current passing through the circuit. But once you close the switch, we are connecting a battery source to the circuit. We are imposing current. And this inductor is very unhappy. He's saying, no, I don't want any change. At first, I have no current. So in order to maintain no current, the voltage will be 20 volts. A voltage will be induced in the inductor. According to the law of electromagnetism, the inductor would develop a voltage of 20. 20 and 20 equal potential, no current flow. Got it? Okay, now, but he cannot resist, cannot maintain this forever. He will have to be weaken and surrender. So this will be 20 to 0 volt. 20 to 0 volt. So if I were to ask you, is this an increasing or decreasing function? You will say it's a decreasing function, right? So the formula is without a bracket. So this is 20 E minus T over time constant. Alright? And what is the time constant for this circuit? Time constant is L over R. So it's 5 milli divided by 6K. Right? So that will be 5 over 6. Our mathematics will come out. My mathematics is bad. Okay, so then we substitute the value. So that is the expression for my VL. How about VR? According to KVL, if here is 20, here should be 0. 0 plus 20 equals 0, right? When here is 19, here is 1. When here is 18, here is 2. When here is 17, here is 3. So while here is decreasing, this one is increasing, right? So your VR is an increasing function. If VR is an increasing function, I ask you to write the expression. It therefore is the one with bracket, right? So it's therefore E1 minus E minus T over time constant. Got it? Alright, so now let's say, write me the current I in the circuit. I again is VR divided by R. If I know the voltage, I divide by resistance, give me the current. So my expression for my VR is with bracket okay, and the resistor is equal to 6 kilo ohm. Okay, so my current expression is with a bracket. So do you know therefore that current is increasing? It's increasing. So finally, the final current in this circuit is just 20 volt divided by 6K, because finally the voltage here will become 20 volts. Right? Finally here is 0, right? So if here is 0, finally here is 20. So the final current is 20 divided by 6K. 6K. So in other words, finally your inductor becomes, the voltage across the inductor becomes 0 volts. Actually finally it becomes a piece of wire. And that is why we say inductor acts as short circuit finally in the steady state, because finally the voltage across the inductor is 0 volt. 0 is just like a piece of wire. So your final, the steady state current is just 20 volt divided by the resistance. Alright, so that is the story of an inductor when it's being in the storage phase, or another similar word will be charging phase. But capacitor we use charging, but for inductor we say storage phase. Okay? Alright, let's talk about the decay phase, where the battery now is being removed. So now it's the opposite already, decay, in the decay phase, right? Okay, time constant still the same. Okay, what would be the story now? The current just now, the current was flowing this way, am I right? And the current was already 20 volt divided by 6K ampere. Okay, finally, remember just now what we talked about? Okay, so now, and we say that the inductor is a very stubborn element. It's a very stubborn element. So you say, okay, I already have current. You suddenly take away my battery. I want to maintain the current. So in order to maintain the current, he must produce the voltage. What is the voltage that he has to produce? He has to produce 20 volts. So your VL now is 20 volt. 20 volt. Right? So 20 divided by 6K, they give you this current. But can he sustain this 20 volt all the time? He can't, because of the energy stored. Once it's used up, right? So 20 volt is to become 0 volt. Okay? So the VL, the expression for VL is an increasing function or decreasing function? It's a decreasing function. Okay? Now, in your EL tag, we learned that this is a battery source. If I say here is 6 volt, here will be 6, 5, 5, 4, 4, 3, 3. So it's the same. So VR is the same value. So VR, if I were to write VR is also the same. Right? VR is also the same. Now let's talk about the voltage VL here. Just now, in my original with that resistor, this, the current was flowing like that, and the VL was like this, right? So you have 20 volt. 20 equal potential. But in order to maintain the current to flow in the same direction, the battery generated must be of this polarity, right? Current flow from positive to negative. But if I maintain my VL arrow this way, don't you think I need to put a negative sign? Because arrowhead represents positive. So the way that I want to measure my VL is the opposite of the actual. So I should put a negative sign. So the expression for VL, when in the decay phase, you have to put a negative value here. VL no change, because VL the current was the same direction. So VL is still the same. How about the current expression? No change also. So it's E minus T or time constant divided by my R. So in the decay phase, or like the discharging, everything is decreasing. So everything is without bracket. Yeah? And why do you have to have a negative sign? It's because my current is maintained the same direction, and with that the polarity of my VL is flipped, and because of my definition still remains no change, so I put a negative sign. Alright? Okay, so that is called the storage and decaying.